had to poll the group for what to do for a topic, and I was told that a couple of people at least, were interested on just what my current thoughts on unit testing are, and then they asked for my opinions on Detroit versus London style unit testing. To which I had to wonder what the hell is Detroit versus London style unit testing. I've been doing this for more than a decade, and this is the first time I've heard of these two schools, basically. I know these are actually just houses and not actual schools. I couldn't find the Beauxbatons crest or the Gryffindor or but yeah, it breaks down into kind of two philosophical schools of how to approach unit testing. The Detroit school is follows a pretty familiar pattern. Write a failing test defining a behavior, implement the minimum amount of code to make that test pass, refactor that code until you're satisfied with that minimum amount, repeat from step one until you're happy. It has kind of an emphasis that separates it from the London school of testing everything that you're using directly and shying away from mocking, indirection, and test doubles usually. So I would, if I were to write a calculator using this, and I actually did, you can see this is kind of what you come up with. There's, in the simplest case, addition, subtraction, multiplication, and division, and then a bunch of symbols that you don't understand, and tests that say, 17 plus 17 is 34, 17 minus 22 is -5, so on and so forth. And honestly, this would have been more interesting as a time-lapse piece of code, but it kind of follows top to bottom in test writing and lines of code here. Probably could have gone through one more pass here to make this a switch statement or case statement instead of an if-else, but I kind of also dislike how case statements look in Java, so that would be a refactoring conversation with my pair partner, driven out through these kinds of things. The London school, on the other hand, focuses more on small, discrete units of functionality and responsibility, I suppose, and it tries to avoid side effects and has a strong emphasis on testing interaction with collaborators, particularly through the use of mocks and test doubles. Here is the same code done through a more London driven. You can see, instead of having just a single calculator class, we have the calculator itself is basically, its responsibility now is just to parse the operator symbol and pass your numbers on to the appropriate mathers, as I call it, which is an interface I define that just takes two numbers and returns another number. Oh, looks like the screenshot I took of the adder wasn't the finished product. Sorry about that, guys. This is an old. This adder test should fail, which is good. But as you can see, the test for the calculator now, instead of saying 2 plus 2 is 4, it says when you get 2 and 2 together, you pass those 2's to the adder and just return whatever the adder tells you to return. Obviously, you can see that this is way more code. But at the same time, when I thought about how I would do this versus this is a bit overkill for 4 operators to have this discrete interface and a bunch of implementations of it for 4 operators. But if I were to start implementing cosine, tangent, exponential things, all the things that you might see on a scientific calculator. It would be nice not to have, 16 or 18 different switch statements here, but rather have just each of them be their own discrete little unit test section. That's kind of where the two kind of tip into one another. When I went through this and read through the fact that there are two schools of thought, I kind of found myself leaning more towards the London school of things, because I prefer keeping my classes and my tests very small, which is usually how the London school code ends up being written. Detroit school stuff, I think, relies a little more on some more clever object modeling and oof. I've completely forgotten the word for the Gang of Four um, book. What were design patterns? That's what it is. So a few more clever usages of design patterns to make them work. There's a lot more uses of private classes to help organize your things for things that are logically similar, but don't necessitate their own interaction testing and things like that. But at the same time, I also see that the foundation of how the Detroit School of Unit Testing will create, I guess, a little more stable foundation for things like refactoring, and that's actually kind of what it came down to here. Is that neither what are tests for when it comes down to it? They're for identifying problems earlier. They're for giving you the ability to refactor confidently. They simplify integration. They help document your code for future generations, and they help drive design. And each of them has pluses and minuses. I wouldn't say either of them are necessarily bad at any of these things. There's just preferable versus unpreferable depending on your school of thought. I think they both help identify problems easier, because because the fundamental loop is the same. You identify a problem, you try to solve it as small as possible, and usually within those discussions, that's when you bring up things like edge cases, or you know unexpected behavior, IO exceptions, things like that. You run into those, like, oh, okay, this thing can possibly throw an IO exception. We better talk to the UX designers about this thing they probably never thought about. What happens when the user is using this and their hard drive fails? We should give them some sort of message, or we should, try to save all their data to memory until they can put in a USB drive or something. Who knows? The Detroit style, or the Temptation style, as I have it on this chart, is definitely better for refactoring confidently. Because the London style places a lot more emphasis on testing collaboration, refactoring a pure refactor is harder. A pure refactor is defined in my mind as a refactor where you don't have to rewrite any of the tests, and you can rewrite as much of the code as you want. That becomes harder when what you're testing is the coupling between classes here and there. I think the London School simplifies integration a little more because it puts more emphasis on the integration of two things. And I also think it helps document a little better because it also kind of establishes better patterns of how to add to things from there on out. If you talk with interfaces and things like that, if you establish interfaces, it kind of helps to kind of lay down that pattern. It also helps to establish the same couple of patterns. I believe this was in some of the articles I read about this, is that London School tends to use the same couple of patterns over and over again, which is factory patterns for kind of dumb dependency injection that is still internally testable, singletons instead of statics for things that need to be mocked and implement an interface so that you can change them around. This is all thinking in Java as well, which is an older, kind of more laborious unit testing process. Anyways, Ruby kind of mixes these two a little more. And then when it comes down to it, design also is pretty well uh, supported by both of these, because you end up with different designs, but I don't know if either of them are necessarily worse or better. It depends on your team and your partner, and really your own mindset on any given day. And so yeah, that's that. If you have more questions about the actual breakdown, the more particular breakdowns between Detroit and London unit testing beyond this really high level overview I gave, all the stuff I read was from a blog by TestDouble, the company. They write good things. If you have more questions about unit testing versus other things, feel free to ask me right now. If you want to hear my thoughts about this versus BDD, I'm still trying to I'm still trying to work that out in my own mind. I'm not settled on that too. BDD seems like kind of like it feels a little more like Detroit style, but it has gaps that I don't quite agree with as far as these particular solutions for it go. So
All right, thank you.